Hey guys, in this video we're going to talk about Chapter 2, Section 1 and Chapter 2, Section 2. These two sections are going to be all about linear functions. So just as a reminder, functions have an input variable. We typically use x to represent the input variable, but we can really use any letter we want. Functions also have an output variable, and we learned last week that we could use y as our output variable, but we can also use these new notations that we learned: f of x, g of x, h of x, and so yeah, we can use that as our output. So today we are going to learn about a very special type of function called a linear function. What I want to do first is I want to give you some real-world examples of linear functions just so you can see what they all have in common. Then what we're going to do is we're going to look at the more abstract definition. But for now, I want you guys to just kind of get your feet wet with what is a linear function. What does that mean in the context of the real world? Okay, so here's a example that I thought of. Let's say you're at a pizzeria and a slice of pizza costs $3, okay? If you buy one slice, how much will you spend? If you buy two slices, how much will you spend? If you buy three slices, how much will you spend? So, the amount of money that we're spending depends on how many slices we're buying, right? So since that's the case, the slices that we are buying is our independent variable because we can choose how many slices to buy. So if I make a table for this scenario, I can say my slices is going to be x. This is my independent variable, what I'm choosing. And let's say that the cost that, how much I'm spending is y. So the cost. That's my dependent variable. And firstly, it says if you buy one slice, how much will you spend? So that means when x is 1, how much do we spend? What's the cost? Well, it's just going to be $3, right? Because one slice is $3, so I'm going to be spending $3. What if I buy two slices? How much am I going to spend? Well, if I buy two slices, I'm going to be spending 3 times 2. 3 plus 3 is 6. If I buy 3 slices, how much am I going to spend? I'm going to be spending $9, right? 3 times is 9. And we can keep going like this. If we buy 4 slices, we are going to spend $12. So the relationship between the number of slices that we buy and what we're spending is a linear relationship. So this is a linear relationship. And what makes it linear? Well, the reason that it's linear is as the independent variable, which is x, how about we just say as x increases by 1, y increases by a set amount. By a set amount. And what is that amount? So we're increasing a set amount from 1 to the next, and that's going to be $3, right? So from 1 to 2, we increase by 3. From 2 to 3, we increase by 3. From 3 to 4, we also increase by 3. $9 to $12 is 3. So as x increases by 1, y increases by a set amount. This is what makes it linear. Okay, so if we had 1, 2, 3, 4 as our input, and maybe we had like 3, 100, 5, and 6 as our output, that's not linear. What makes this linear, again, is that the y values are all increasing by a set amount as x increases by 1, right? So as x increases by 1, the y values are increasing by a set amount. That's what makes this linear. Let's look at another linear situation. So as I just mentioned in the previous slide, input and output I use interchangeably with independent and dependent variables. Remember, independent variables are inputs and dependent variables are outputs. So as I just mentioned in the previous slide, as the input increases by 1, the output increases or it could decrease by a set amount. Remember in the pizza example, the output value was increasing by a set amount 3. Let's take a look at this example. So we start with $100 in a savings account, and each year we earn $20 in interest. So let's make a table. First of all, we need to choose our independent variable and our dependent variable. Well, here is a pro tip. 99% of the time, your time is going to be your independent variable. Okay. So here, each year, we're talking about years here. So year 0, year 1, year 2, year 3. So this X is going to be our years. That's our independent variable, time, pro tip. And our output is going to be how much we have in the savings account. So it says that we start with $100 in the savings account, which means that year 0, before any interest accrues, we have $100. Right? So this is how much money we have. Okay. Now it says each year we earn $20 in interest. So how much are we going to have after, at year 1, after year 0 is passed? Well, we're going to have 100 plus 20, which is 120. Right? We increased by 20, assuming we don't deposit any more money in the savings account. Now year 2, we're going to have $20 more from the previous year. Right? Each year we accrue $20 in interest. So in year 2, we're going to do 120 plus 20, which is 140. So again, we're accruing $20. Year 3, same idea. We add 20 to get 160. So this is also a linear relationship, right? Because as our years increase by 1, right? Oops, sorry. Uh-oh, here we go. So as our independent variable increases by 1, our dependent variable also increases at the same time by 20, right? So this represents a linear relationship. Let's write it out. This is linear because as X goes up by 1, Y goes up by 20. So this is the definition of linear. As the input increases by 1, we see that here. As the input increases by 1, the output increases or decreases by a set amount. In this case, the set amount is 20. All right, so that's what makes this linear. Let's look at another example where we're actually decreasing by a set amount. All right, so let's say we buy a new car and it's $25,000. And let's say its value depreciates by $2,000 every year. This is linear. As the years go by, we're decreasing the value of the car by $2,000 each year. All right, so let's make a table out of this and let's define our variables. Now we have two things. We have cost and we have years. Now remember our pro tip. X 99%, probably 99.9% of the time is going to be time, right? That's our independent variable. How many years go by? So we're going to say that X is going to be our years that go by. Let's say year 0, 1, 2, 3. Year 0 is always the starting amount. All right. And let's say that Y is going to be the value of the car. Right? So Let's do this. Okay, so year 0, how much is the car worth? Well, it's worth $25,000. Car is worth $25,000. It depreciates by $2,000 each year. So how much is it going to be after that year 0? Well, we're depreciating by $2,000, so it's going to be $23,000, right? So this is going to be depreciating, which means it's subtracting $2,000. Now it's only worth $23,000. Now year 2, again, we're subtracting $2,000, and this is going to be $21,000. I know I'm doing the dollar sign at the end. That's kind of weird, but whatever. Okay, year 3, how much is it worth? Well, subtract another $2,000. That's going to be $19,000, and we can keep going on like this forever and ever. And so we can see that this relationship is linear. Why? Because as we increase x by 1, as we increase the input by 1, the output is decreasing by a set amount. The output is consistently decreasing by $2,000. So this shows a linear relationship. And let's write it out. So this is linear because as x increases by 1, y, our value of the car, decreases by $2,000. So that's the set amount that it decreases by. So this is a linear relationship. Okay, let's determine whether or not these situations are linear or not. Let's look at number 7. Let's look at the first one. For every minute that passes, 4 liters of water leaks out of a tank. There is initially 100 liters of water in the tank. Is this linear? Well, yeah. For every unit of time, for every minute, 1 minute, 2 minute, 3 minute, 4 minute, a set amount of water is being leaked out of the tank. That's linear, you guys. So let's make a table for this. So what's our x and our y? Well, again, x is time, always time. So x is going to be the minutes that passed, and y is going to be, well, what's left? How much is in the tank? This is going to be water in the tank. So at minute 0, before the clock starts, how much water is in the tank? Well, this is our initial value. Whenever x is 0, our initial value is our y value. So this is going to be 100, right? We start out with 100 liters in the tank, and then a minute passes by, and how much is in the tank? Well, 4 liters leak out every minute, so this is going to be 100 minus 4, which is 96. So it's minus 4. Minute 2, again, 4 liters leak out from 96, so 96 minus 4 is 92. Okay, and so forth and so forth. So this is linear because as x increases by 1, as the minutes go by, a set amount is being taken away, right? So as a minute goes by, 4 liters is being leaked out of the tank. So that is definitely linear, yeah. What about this little table right here? So it looks like our x values are all increasing by 1. So plus 1, plus 1. Now the question is, are the y values increasing or decreasing by a set amount? Well, yeah, 4 to 6 is plus 2. 6 to 8 is plus 2. 8 to 10 is plus 2. So yes, this is linear. This one was also linear up here, right? Let's look at this situation here. At a video game rental store, members rent Nintendo games for $2 a night. The club also charges a $20 annual membership fee. So this is like a fixed cost. So is this linear? Well, let's make a table. So we have x, we have y. This is our independent and dependent variables. So again, per night, okay, that's time, right? So that can be our x value. So this is 0, 1, 2, 3, 4. This is how many nights we rent a game. And y can be the costs that we spend. Now, if we don't rent any games, we still have to pay the $20 annual fee. So if we rent for 0 nights, we're still going to pay that annual fee. So this is going to be our initial value, which is $20. After 1 night, I am going to spend $2 in addition to my set annual fee. So this is going to be $22. If I rent the game for 2 nights, I'm going to pay $24 in total, right? The set fee plus the 2 times 2, 26, 28, etc. So yes, this is linear because as x goes up by 1, as the amount of nights go up by 1, my cost that I'm paying is going up by 2. Right? So that is indeed linear. So for all the situations we just looked at, we can actually write equations that represent each of those situations. We don't just need like a table like we had before. So if a function is linear, it can be written in the form y equals mx plus b. We call this form slope-intercept form. And m, this number attached to our x, is the rate of change or the slope. So this is the set amount that we're changing from 1 year to the next, or 1 minute to the next, or whatever. And then b is our starting value. So like, for example, with the car example, we start at $25,000. That would be our initial value. We call it the y-intercept. We also can call it the vertical intercept if you like that better. Initial value, starting value, these all are the same thing. This is b. So let's look at each of the situations we just discussed and write it in y equals mx plus b form. Then we're going to explain what each letter represents in this form. So we already established that all of these are linear. So they can all be written in y equals mx plus b form. So the first situation is we start with $100. Each year we earn $20 in interest. So remember what our table looked like. We had x was in years and y was in dollars. So these are our units, all right? So we started at year 0. We started with $100. So that's going to be our b in y equals mx plus b. So b is going to be $100. All right, so far so good. Now, when year 1 comes, we have 120, right? So this is going to be how much we have with the $20 in interest. In year 2, we have 140, etc., etc. So our m, our rate of change, is this set amount that we're adding, which is 20. So how much are we changing from year to year? We're changing by $20. So m is going to be $20 per 1 year. Okay? Does that make sense to you guys? So m is going to be the amount that we're changing for every year. And I want to include that 1 year in the denominator because, so these are the units, dollars per year for the slope. So for every 1 year that goes by, we increase by $20. That is our slope. Okay, cool. So far, so good. We have m, we have b. Now, what are x and y? What are these things? So remember that x is going to be the number of years, and y is going to be the money we have at year x, whatever x is, right? So these are going to be our values here. So in y equals mx plus b form, to write my equation, this is my answer, by the way. I have y equals 20. I don't need to really write the fraction. I can just kind of write 20 as it is, x plus b. So this is our M, and this is our B. Now, why do we leave X and Y alone? Well, we want to write it as a function. We want to be able to choose any X. If I want to figure out, hey, how much money am I going to have after 100 years? I want to be able to leave that X as it is so that I can plug 100 in and get out an answer for Y. All right. So whenever you're writing a function, you want to leave X and Y alone. You want to just sub in numbers for M and B because those things aren't changing, but X and Y are going to constantly change depending on what you want to figure out. You know, if you want to figure out how much money you have after 70 years, you want to plug in X equals 70, get out a Y value. All right, so that's the idea here. All right, let's do this car example. So let's do our XY table. So remember we had X was, again, the years, and Y is the value of the car in dollars. So we had 0, 1, 2, 3. We can keep going if we want, but, you know, we can, whatever. Okay, so at year 0, we know that the car is $25,000. And it depreciates by $2,000 every year. So minus 2,000 from 25,000 is 23,000. Again, minus 2,000 is 21,000. Again is 19,000, and it keeps going in this pattern. So here we go. We're subtracting 2,000 from each of these guys. So as X goes up by 1, Y decreases by 2,000. So let's figure out, remember, we're trying to write this in mx plus b form, and we need m and we need b. X and y we leave alone, right? Because we want x to be a variable so that we can plug in whatever we want, right? Okay, so b is the initial amount, which happens when x is 0. That's our initial amount. Our very starting value is our initial amount. So here, B is going to be 25,000. That's our starting value. What about M? So M is going to be minus 2,000, right? But let's include units here. We're not just saying the change is minus 2,000. We're saying we're subtracting $2,000 per year. That's our change. So our slope is going to be minus $2,000 per 1 year. That's my change. That's my rate of change. Cool. So what's our equation? Our equation is y equals minus 2,000 x plus b. Plugging in m and b into my basic equation. So this is my answer here. Why do we leave x and y alone? Let's really get into that. So what if I asked you, how much will the car be worth in 10 years? What if this was a question? How much will the car be worth? Well, you could, say, okay, well, at 4 years, we subtract $2,000 more and get 17,000, and we can keep doing that until we get to 10. But that's kind of tedious, right? We have an equation that's going to give us that answer, right? When x is equal to 10, what is y going to be equal to? That's what we want to know. So our answer here, we just plug in 10 for x. We have this nice little function that's going to do the dirty work for us. And let's figure it out. So if we take 2,000, or negative 2,000 rather, and multiply it by 10, we get negative 20,000 plus 25,000, which is just 5,000. So therefore, therefore, the car will be worth $5,000 by year 10. Okay, I hope that makes sense. So that's why, we write a function to figure out what's going on way far in the future so that we don't have to make this really tedious table, okay? We have infinitely many values we can plug in for x, right? Now, some of the x values aren't going to make sense. For instance, what if I plugged in -3 for x? That doesn't really make sense, right? So sometimes our real-world models are going to exclude certain values because they don't make sense. It doesn't make sense for time to be negative. Anyway, all right, cool. So we got that one done. Let's go ahead and look at this guy, this tank example. For every minute that passes, 4 liters of water leaks out of a tank. Initially, there's 100 liters of water in the tank. What are we trying to do? We're trying to figure out what M and B are in this example. All right. So remember what our table looked like. We had X, and our X was time in minutes. That was our unit here. And our Y, our output value, was how much water is in the tank. And that was in liters, okay? So at minute 0, we initially had 100 liters. So that's our B, all right? So we already know what B is. B is 100. That's my starting amount. Now at minute 1, it says that 4 liters leak out every minute. So 100 minus 4 is 96 minus 4. At minute 2, 96 minus 4 is 92. And so forth. Minute 3, we have 91, 98, 88. So as we increase the minutes by 1, we decrease the amount of water in the tank by 4 liters. So my M, remember, it's going to be, your units are going to be how much you're changing in Y over how much you're changing in X. So I'm changing by 4, so this is going to be minus 4, and my units are going to be liters per minute. Does this make sense? Am I changing by minus 4 liters per minute? Well, yeah. The amount of water that's left in the tank is decreasing by 4 liters per minute. So that's my M. So we got that. So our equation is Y equals M X plus B. Very nice. Now, what if I asked you this? All right, let me just pose a question here. I'm going to pose a question. So when is the tank going to be empty? How can we figure that out? When is it going to be empty? So what does that mean in terms of our variables? Like, what do we know and what are we trying to find? Well, if I'm asking the question when, I'm trying to find time, y'all. I'm trying to find X. So the question is, what is X when Y equals, well, 0, right? Because Y is the amount of water that's in the tank. I'm trying to figure out when it's going to be empty, so I'm trying to figure out when Y equals 0. Now we have this awesome equation that can help us find exactly that. What I'm going to do is I'm going to sub in 0 for Y, and I'm going to figure out what X is that way, because I'm only going to have one unknown when I do that. So let's go ahead and do it. Let's hammer it out. So when Y is equal to 0, let's plug in 0 for Y into my equation. We have negative 4x plus 100. And we know how to solve equations like this. I'm trying to figure out what X is. So what I need to do is I need to isolate X by first undoing addition of 100, subtract 100 from both sides, and I get negative 100 is equal to negative 4x. Now I want to undo multiplication by negative 4 by dividing both sides by negative 4, and I get x equals 25. So what does this mean? Therefore, ... after 25 minutes, remember x is minutes, the tank will be empty. All right, so that's, one example of a real world context here. All right, so here's our situation. This is pretty straightforward. This is more abstract because we're not given a little story here. You could make up your own story if you wanted, but here we're just given a t-chart. So what's M and what's B? Well, B always occurs when X is 0. Let's write that as a note here. B is Y when X is 0. Now, Y isn't always Y. It could be f of X, G of X, f of T, whatever. But just for simplicity's sake, I'm going to call it Y for now. Okay, so we know that B is 4 because that's Y when X is 0. Now, what's M? Well, look at X. We're changing by 1, so that's good. We're changing by 1. What's happening to Y? Well, we're adding 2 to get each next term. So add 2, add 2, add 2. So therefore, M is going to be 2. We're not given units here, so this is just going to be 2. All right. So our equation here is Y equals 2X plus 4. Y equals MX plus B. That is our equation there. All right, let's do this situation at a video game rental store. We have X, we have Y. So remember, X was the nights that we rent the movie, and Y was going to be the cost in dollars. And so, you know, we had 0, 1, 2, 3 for our nights. Night 0, we're only paying $20 because we're not paying anything for like renting games. But if we rent a game for one night, it's going to be $2 per night. So this is going to be a grand total of $22 that we're paying, plus 2. If I rent a game for 2 nights, I'm going to be paying a grand total of $24, again, plus 2. For 3 nights, $26, and so forth. So as I'm increasing by 1, as X is increasing by 1, Y is increasing by 2. So that tells me that my slope is going to be $2 per one night. That's how much I'm changing by, $2 per night. The cost is changing $2 per night. That's my slope. Notice that my units on top is my Y units, which is dollars. On bottom, my X units is nights. So this is my slope right here, you guys. Now my B is going to be my starting value when X is 0. When X is 0, Y is 20. So my B is going to be $20. All right. So altogether, my equation is going to be Y equals M2 X plus B plus 20. And this is my answer right here. It's my equation. And again, just to hammer this down, this is going to allow me to figure out the cost that I'm paying for any amount of nights. If I want to figure out how much I'm going to be paying for 10 nights, 2 times 10 plus 20. So that's $40. If I want to figure out 180 nights, 2 times 180 plus 20. So yeah, that's my equation that represents the situation. Okay, express the value of a company's cumulative operating costs after M months as a linear function of M. When it says a linear function of M, that means that M is acting like my X, okay? So in your homework, you might see like a linear function of T. That means that we're writing Y equals MT plus B, okay? Or instead of Y, it could be F of T equals MT plus B. So M is acting like my X here, okay? And it says if it needs $7,900 for equipment, furniture, etc., and if the rent is $3,600 per month. So we need to figure out what this is in Y equals MX plus B form. But instead of Y, I'm going to call this, well, I guess I can call it Y. Let's call Y equals M instead of X. Well, this is kind of confusing. I don't like M. How about we do T instead? Let's change this problem out. Let's change it up a little bit. Instead of M, let's say our X variable is T. So what we're looking for is Y equals MT plus B. All right, so T is acting like our X variable. And what I can do just to kind of get my feet wet here is I can make a table for my input and my output. So my input is t and my output is y. And what are the units for each? Well, t we're told is months. And y is just going to be how much we're spending again. So this is going to be the cost in dollars. Okay? So you always want to see what's happening at month 0. All right? So, what are the costs going to be if before rent starts accruing? Is basically what that is. What's the startup initial cost? Well, we need $7,900, right? That's for equipment, furniture, etc. So if I'm not paying any rent at month 0 before I start paying rent, this is going to be $7,900. Now, month 1, I have to pay 1 month's worth of rent, right? So what is this going to be? Well, this is going to be my startup cost, $7,900 plus the $3,600 for rent, right? And what is this going to be? So this is going to be $11,500. Okay. Month 2, I'm paying 2 months worth of rent, so I still have this fixed cost of $7,900 plus $3,600 now times 2 because I'm paying 2 months worth of rent, right? So $3,600 times 2 plus $7,900. Hopefully you guys are seeing the pattern here. The next one is going to be $7,900 plus $3,600 times 3. Let's just do it right here. Okay, and we get $18,700. So what's the rate of change? Like how much am I changing from 1 month to the next? So plus 1, we're increasing by 1. How much is y increasing from month to month? Right? Well, it's increasing by $3,600, right? So here plus 3,600 plus 3,600 plus 3,600. So this guy is going to be my slope, all right? So m is going to be, what are my units here? Well, units for y over units for x. This is going to be $3,600. So units is bucks per month. That's how much I'm changing by. So this is my m. Now what's my b? B is my initial value, my starting cost when my x is equal to 0. So that's going to be $7,900. All right, so we have everything we need. We have m and b. So my final answer, my equation is going to be y equals 3,600t, that's acting like my x variable, plus b, which is $7,900. So this is my equation that represents the situation here. Okay, you buy a saguaro cactus 6 feet high, and it grows at a rate of 0.2 inches each year. Express its height in inches, h, as a function of time. So we know that time, t, is acting like our x, and so our y is acting like h of t. So in this case, y is equal to h of t, and x is equal to t. So these are like our independent and our dependent variables here. So let's go ahead and just sketch out a t chart here. So our independent variable is t, and this is going to be in years. All right, so this, remember that our independent is always time, if time is a variable. Then we have h of t, which is our output, and this is going to be our height of the saguaro cactus. So when we buy it, that's year 0, right? It's 6 feet high when we buy it. So at year 0, it's 6 feet. Okay, and this is in feet. All right, so our units for our slope, we know are going to be feet per year. All right, so year 1, well, we have to add 0.2 inches because it's growing by that much per year. So this is going to be 6.2, right, plus 0.2. Year 2, we have again, plus 0.2, it's going to be 6.4, etc., etc. So here, what is my slope? My slope, I'm growing 0.2. Oh, I'm sorry. This is, let's see. You know what we're going to do? I actually messed up here because, look, we're in two different units. We're in feet and inches. Let's change feet into inches so that we can add these things. Let's get rid of this really quick. Got to be careful sometimes. So we know that 12 inches is in 1 foot. Therefore, in 6 feet, that's 6 times 12, which is what? That's 72. So 6 feet is equal to 72 inches. So let's just do this in inches, actually, instead of feet. So instead of 6, I'm putting 72 because I want to make sure that everybody's in inches. All right. So 72 inches, 72 plus 0.2 is 72.2. Then I have 72.4. So again, I'm just increasing by 0.2. And this time, so my slope is going to be 0.2 inches per year. So my units are inches per year for my slope. My B is my starting value at year 0. That's 72 inches. And this is all I need to know. So my equation is y equals m, which is 0.2. Oh, you know what? Sorry, instead of y, let's do h of t. And then instead of x, we're putting t. So 0.2t plus b. So this right here is my final answer. Again, h of t is y, and t is acting like x in this case. Okay, so let's practice identifying the slope and the y-intercept from linear expressions and equations. So this first one, we have f of x, aka y, equals negative 2x plus 4. So again, we're trying to figure out what m and b are in this, okay? So m is the number that's attached to x by multiplication. In this case, it's negative 2, so m is negative 2. And then b is the constant number at the end, so b is going to be 4. So that's our answer for number 1. Okay, let's look at number 2. We have y equals 3x. So m, again, is this number attached to x, so m is going to be 3. What's b? Well, we don't see a b, so b is assumed to be plus 0, right? So b is going to be 0. That's our answer here. Okay, number 3, we have g of x equals 8, so like y equals 8. You want to think about it like that. Now we don't see an x here, which means that secretly we have a plus 0x. You see that? So in this case, our number attached to x is 0, and our b is going to be our constant, which is 8. All right, let's look at number 4. Now this isn't in y equals mx plus b form, but we can certainly use the distributive property and combine like terms so that it is in y equals mx plus b form. So let's start with the distributive property and distribute this negative 2 in there. So when I do that, I get y equals negative 2 times x is negative 2x. Negative 2 times negative 4 is a positive 8. And I still have this plus 6x minus 1 at the end. Now I can combine like terms. So negative 2x and a plus 6x makes a plus 4x. And a plus 8 minus 1 makes a plus 7. So this is in y equals mx plus b form, and we can see that m is 4 and b is 7. And that's our answer here. Okay. Number 5, we have 68 minus 20x. If it helps you, you can write the x term in front. So like we can rewrite this as f of x equals negative 20x, and the 68's positive because there's an understood plus sign in front of it. So this is like that, and maybe it's easier to see now. So the number attached to x is negative 20. So we have m equals negative 20, and the constant number at the end is plus 68. So B is 68. That's our answer there. All right, so here we have y equals x over 3 plus 14. Now we can rewrite this to make it look more familiar. If I rewrite this, this is y equals 1 over 3 times x plus 14, right? This is the same exact thing as this, same exact thing, it's just written a little bit differently. So now we can see the number multiplied by x is 1/3, and the constant number at the end is 14. Therefore, m is equal to 1/3, and b is equal to 14. Okay, let's look at this last one. We have f of x equals 20 minus 6x over 7. Now, since we're all over one number, we can separate this into fractions. So this is the same exact thing as, well, 20 over 7 minus 6 over 7x. Same exact thing, right? If I have the same denominator, I can combine the numerators like this, right? Same exact thing. So now this looks a little bit more familiar. The number that's attached to x is negative 6 over 7. So m is negative 6 over 7. And b, my constant number, is a positive 20 over 7. So those are my m and b's. Which lines have the same y-intercept? Remember, this is b, and y equals mx plus b. So these three are all good. We don't have to really do anything. They're in y equals mx plus b form. But the first two we need to rearrange a little bit so that these things are in y equals mx plus b form. And to do that, we need to get y by itself for both of these equations. So for the first equation, let's do that. We have x minus 2y plus 6 equals 0. And I'm trying to get y by itself to get into this form right here. So I need to move everybody over except y. So what I'm going to do first is I'm going to move this positive 6. I'm going to get rid of it by subtracting 6 from both sides. So let's rewrite. I have x minus 2y equals 0 minus 6, which is minus 6. And then what I can do is I want to undo a positive x. How do I undo addition by x? Well, I can subtract x from both sides. So let's rewrite. I have negative 2 times y equals negative 6 minus x. And finally, what I want to do is I want to divide both sides by negative 2 to get y alone. So I have to divide everybody by negative 2. Everybody, both of these guys, by negative 2. I have two terms, negative 6 and negative x. They both need to be divided by negative 2. So when I do that, I get negative 6 divided by negative 2 is positive 3. A negative x divided by a negative 2, those two negatives being divided make a plus, right? So this is just plus x over 2. Now, to make it look more familiar, we can do like we did in the previous slide. X over 2 is the same thing as 1/2 times x. So this is 3 plus 1/2 times x. All right, so let's rewrite this as y equals 1/2 x plus 3. Okay, so that's the same thing as this. So now we're in y equals mx plus b form. It's easier to see. Now let's do the same thing for part 2. Let's put that guy in y equal mx plus b form. Let's do this. Okay, so I have 2x minus y equals 3, and I want to get y by itself. So I can do this a couple different ways. What I'm going to do is I want the y to be positive, so I'm going to just start by adding y to both sides to make it positive. And I have 2x equals 3 plus y. Now on the right side, I want y to be by itself, so I can go ahead and subtract 3 from both sides to do that. Okay, so I get y by itself, which I wanted, is equal to 2x minus 3. All right, so let's write that down here. This is secretly y equals 2x minus 3. Okay, so now everybody's in y equals mx plus b form, and I need to figure out which of these have the same b values. Well, let's see. So for 1, what is b? B is going to be 3, right? That's that constant at the end. For number 2, b is going to be negative 3. For number 3, b is going to be 2. This goes with that goes with that goes with that. And then this guy, what is the y-intercept here? Well, it's going to be negative 3, right? Now, this one's a little bit tricky because it's not, we don't even have a y. We don't even have y equals mx plus b form. This is actually just a vertical line that goes through x equals 2. So this is x equals 2, and so the graph looks like this. So yes, it is a line, but it doesn't have any kind of slope, and it actually doesn't have a y-intercept either because it doesn't, it doesn't cross the y-axis, which we're going to get into in a few slides. But the point is, if you see something like this, there's no b, there's no m. Okay, so just get rid of that. So which of these have the same y-intercept? Well, our answer is going to be 2 and 4. So 2 and 4 both have negative 3 as the y-intercept. So that's our answer here. Okay, so there is a way to find the slope or the rate of change and the y-intercept given two ordered pairs. So it's super easy. If we're given 2 points, we can figure out everything we need to know. And the way that we do it is with this formula right here. It says the slope, which is m, is equal to y2 minus y1 over x2 minus x1. Now, what do the y's and x's mean? Well, we know that one point is going to be called x1, y1. This is point 1. And then another point, point 2, is going to be called x2, y2. So those are what those letters represent. So let's do some examples. It says, find the slope of the line that passes through the points -3, 4, and 1, 2. All right, so we're just finding the slope of a linear function. In a few slides, we're going to actually talk about the graphs of these linear functions, but for now, let's just look at this algebraically. So point 1, point 2, it doesn't matter which one you pick for point 1 or point 2. So I'm just going to pick the first one is point 1, so we'll call -3 x1 and 4 y1. And then the second point can be point 2 x2 y2. So using our formula, we have m equals y2. Well, y2 is going to be 2 minus y1. y1 is going to be 4 divided by x2, which is 1, minus x1, which is -3. All right, so on top, 2 minus 4 is -2. On bottom, remember these double negatives make a positive, so 1 plus 3 is 4. And if I simplify by 2, divide top and bottom by 2, I get -1/2. So this is my slope of the line that goes through those 2 points, the linear function. Okay. So next example, write an equation in slope-intercept form for the line that passes through -1, -3 with slope m equals 1/2. All right, so we want to write this in the form y equals mx plus b. And the question is, what is m and what is b? If we know these two things, we can easily write the equation. Well, we know what m is. It tells us it's 1/2. So we already have half of the problem solved. Now we need to figure out what b is. So when they tell you that it passes through that point, that means that this is an xy coordinate. So this is our input x, and this is our output y. It's just a point that satisfies that equation. So we know that x is equal to -1 and y equals -3. We also know that the slope is 1/2. And so what we're going to do is we're going to use these things to solve for b in this equation by subbing in each number in here and figuring out what b is that way. So we have y, which is -3, equals m, which is 1/2, times x, which is -1, plus b, which we don't know. Okay, now this is just a regular equation. We're solving for a variable, which is b, and we just want to, condense this as much as we can and then solve. So on the right side, if I do 1/2 times -1, that's going to give me -1/2. All right, so here I am. Now I want to get b by itself, so I need to undo subtraction of 1/2 by adding 1/2 to both sides. Now you can do this by hand, or you can do it on Desmos. So let me show you how to do that really quick. Let me show you how to put this in Desmos. So we have -3/2. Let's see if it's going to load. All right, so here I'm just on Desmos.com. So I have -3 plus, and then what you want to do is, let's see, if I go to ABC at the bottom left, never mind, let's go back to 1, 2, 3. Well, I think this is going to work. I just do 1 and then the division sign and then 2, and then it gives me my answer there. So if you're lazy like me, you can just use a calculator to do this. So there I go. I have b. I know what m is, and so my final answer is going to be y equals m, x plus b. So this is b, and this is m. Okay? All right. Write a formula for the linear function whose graph intercepts the x-axis at x equals 20 and the y-axis at y equals -3. So we need to take this information and get 2 ordered pairs from it. If we get 2 ordered pairs, we have everything we need. So what this looks like is, we have this point on the x-axis. It says it hits the x-axis at 20. Well, if it hits the x-axis, that means it's not going anywhere vertically, and so the y value, therefore, is 0. All right? So that's what that first part means. It intercepts the x-axis at x equals 20, and then it says it intercepts the y-axis at y equals 3. -3, sorry. So if it intersects the y-axis, that means x has to be 0, right? X has to be 0, and y, therefore, is -3. So that's what this means, okay? And because that's what it means, we have 2 ordered pairs, and that's all we really needed to do the problem. So our first ordered pair is 20, 0 from this part, and our second ordered pair is 0, -3 from this part. So let's figure out what the slope is first. Again, we're trying to find m and we're trying to find b so that we can write this in y equals mx plus b form. So I know how to find the slope. I can call this point 1, x1, y1, and I can call this point 2, x2, y2. So again, my slope is going to be y2, which is -3, minus y1, which is 0, divided by x2, which is 0, minus x1, which is 20. Okay? So then I do this. -3 minus 0 is -3. 0 minus 20 is -20. And those double negatives make a positive to give us a slope of 3/20. So this is m. All right. Now that I have m and I have points, I can just sub in those values into y equals mx plus b and solve for b. So it doesn't matter which point you pick as your xy point. It really doesn't. I'm going to just pick this guy as my xy point, but you could have easily picked this guy as x comma y. You're going to get the same answer. So here, since I'm picking this point, x is equal to 20 and y is equal to 0. And we just found m, by the way. M is equal to 3 over 20. So subbing each of those values in here and solving for b, I get 0 equals 3 over 20 times 20 plus b. These 20s cancel. 3 over 20 times 20 over 1 is simply 3. So I get 0 equals 3 plus b. Subtract 3 from both sides, and I get b is equal to negative 3. So I know b and m, so my equation is y equals 3 over 20 for m, x plus b. This is my answer right here.